Let me tell you a little bit about myself while everyone is coming in. As he mentioned, my name is Roaa Khaddam, and you can also say Rüya in Turkish. I'm a senior Flutter developer, and also I'm a Flutter and Dart GDE. I'm working currently at Widgetbook, working on an open source package that enables Flutter developers to catalog their widgets and build them in isolation, to test them on different screen sizes, locales, and themes. I started working with Flutter 3 years ago, and aside from building multiple applications, I've always had a passion for animation. I started tinkering with motion graphics and web animation. And when I started with Flutter, I immediately discovered how easy it is to create animations with it. So this is what I want to talk to you about today. But before we get into the technical stuff, let me tell you a little story. This is a UI UX designer. He has been tasked by a very demanding client to build a very creative UI. And after a lot of work and client feedback, he came up with this design prototype. So this is what the designer came up with. This is the prototype. It's a recipe app. There's a list of recipes. It's animating. And when you open a recipe, there's also a lot of animations happening, a lot of things rotating. And the client was finally happy after like 100 iterations. And the designer was also happy, getting a lot of likes on Dribbble. But the developer was a bit stressed out because he had to implement this in code. But we don't need to do that yet. We can, in this talk, we will see how this kind of animation can be created from scratch using Flutter. And also, we are going to get one step ahead of the designer and developer and make this animation look amazing on web as well. So to do this, we are going to cover the following topics. First, we're going to see how we can do scrolling animations with lists, grids, and slivers. And before we go into very complex topics, we're going to cover the basics of Flutter animations. And we're going to see how a complex hero animation can be implemented. The hero animation that I refer to is the, like if you remember from the cheesecake, it was transitioning from the previous to the next page. So we will see how we can implement that. And we will implement a gyroscope effect, which means that elements will move when you move your phone. However, for web, you don't have a phone, so we will implement an alternative solution for that. And finally, this will be the Flutter implementation. So I'm both the designer and developer in this case, so I didn't do it design first. This is actually the Flutter app, but with a little bit of After Effects magic. So this is all Flutter. And this is what we will see how it can be implemented. And also, for the web, it will look like this. As you see, the list is a grid now, and instead of a vertical view, you have a horizontal view. This link, I will show you a QR code for it at the end, so you can see it. Let's start first with animating the list view. As you may know, first of all, let me ask a question. Who here did Flutter, like knows Flutter? Okay, awesome. Awesome, that's very awesome. Okay, who here created animations with Flutter before? Ooh, nice, nice. Okay, for those of you who don't know Flutter or aren't actually familiar with it a lot, I will try to do this as generally as possible. It's just code. No need to be to be scared of it. It can be like, I think it can be understandable to anyone who programs before. So for those of you also who knows Flutter, hi. I'm very happy you're here. I'm very happy you're all here, by the way. I was so stressed at the beginning, I couldn't say hi, everyone, so yeah. Okay, so we have list views in Flutter, scrollable, like a widget that contains multiple children, scrollable children, and we have a builder method for some of those list view or grid view widgets. This builder method helps us such that each child is built just as soon as it gets into view. So before that, nothing, like it's not rendered. So this helps performance, because imagine if you have like 1,000 items in your list, so they're not built at once, just when each item is built into screen. And this actually can help us with our animation we can do a little trick to tell it that once it enters the screen, launch the animation. And we can do that in the init state. Let me see here. Okay. In the init state method, we have our animation controller. I will get into it in a little bit. And just calling forward in the init state will cause the animation to run as soon as the list item is built into view. To do this in a more reusable and optimized way, I usually prefer to do this syntax. I create a widget, name it child wrapper. And when I have a list with an item builder, I wrap the child with this widget so that I can run all my animation code in it. And whatever child I can give it, it will animate according to it. And also this way, I can use an automatic keep alive client mixin with the state object of the wrapper widget and give it a keep alive parameter that allows me to run the animation once or every time it enters. So if you scroll in and out and then in again, you might want the animation to happen only on the first time. This is where keep alive is true. Otherwise, it can be false and it will run every time. So here's what the recipes list looks like. There's a little bit of a trick for performance. Okay, you see a grid view, but the item count is 1 for small screens, so that it becomes a list, and 3 or 4 for big screens. And it returns the recipe list item wrapper. This is where all the animations are happening. Also, quick note, you have to set cache extend to 0 to make the animation run as soon as the widget gets into screen. Otherwise, Flutter does some calculations and the cache extent might not be 0, so it might run a little bit before it's into view. And you might note that when the list is animating, when you're scrolling down, the animation is different than when you're scrolling up. This means that the direction, you see this, this item is different than this one. This is depending on the scroll direction. So to achieve that, we need to, in some way, listen to the scrolling that's happening and find out in which direction it's happening. We have 2 ways to do that in Flutter. We can wrap the list with a notification listener and give it a type of user scroll notification, like so. And in the onNotification method, we can preserve the scroll direction value and later pass it to the recipe list item wrapper. By the way, I'm using a value listenable builder instead of doing set state so that not everything gets built, and I can use the child parameter to use the list item, to get the list item inside of it. So in fact, everything is building when you're scrolling. However, these child widgets inside builders, they don't get rebuilt. This is the objective of every builder widget, so to optimize for performance. Let's see how the recipe list item wrapper build method looks like. Ignore the animated builder for a second. We will get into it later. But you can see here that we have 2 transform widgets, one for the perspective and one for the scale. Because if you remember from the list, each item, when it gets into view, the perspective is, we will know what perspective is in a minute. It's distorted, and the scale is also going from small to big. And this is the perspective I'm talking about. So technically, this looks like it's rotating in 3D. However, the way Flutter does this is that it actually just scales down the object in Y or X axis to look like it's rotating. But in fact, it's not 3D. And to use it, transform widgets take a matrix, a 4x4 matrix. And the easiest way to do this is to assign an identity matrix and set the values for it. In this case, we want the Y value, and this Y value is the third row, first column, if you have the starting position as 0. And before we go any further into more complex stuff, let's establish the basics of Flutter animations. We have 2 types of animations in Flutter, implicit and explicit. The implicit animations are the simplest. They are animated foo widgets, where foo stands for the property that you're going to animate, just like animated padding, animated rotation, and so on. It's enough to give them a value, that you set state on or change it in any way, and it will automatically, with a duration and optional curve, it will automatically trigger an animation. And also, if there is no animated full widget that fits your objective, you can use a tween animation builder. This tween animation builder widget is still an implicit animation with more flexibility. So you can select, you can give it a tween. The tween class is simply a class that helps you animate between two values. And when you set state on one of those values, you will trigger an animation implicitly. By the way, implicit and explicit, meaning implicit is, it's a given. It doesn't need to know a lot of stuff. It doesn't need to be controlled. Explicit animations, however, need to be explicitly, like directly told what they should do. And they are told that using the animation controller. The animation controller takes a vsync value, and this vsync value is not so scary. It just hooks the widget to the Flutter's 60 frames per second rendering and allows the animation to run. And on that animation controller, you can call forward, you can call reverse, you can call whatever you want to tell the animation when to animate. Different from the implicit animations, which you weren't able to control when they animate. They just animate when you set state. You can't control all that that you control with explicit animations. So now we can go to the recipe list item wrapper and see the animated builder. This is a form. This is a widget for explicit animations, and it takes an animation controller. And these values, these are actually animation values hooked to the animation controller and animate with it, and using them inside the builder of the animated builder causes the animation to run. So now back to our animation. We want to define values to change, remember those perspective and alignment, we want to change them according to the scroll direction. This is done, like the scroll direction is forward when you're going up and reverse when you're going down, and we want to apply -1 and 1 to like multiply the perspective with it so that this change here in direction is applied. Similarly, the alignment is the origin from which the scaling down happens from, and changing that with the scroll direction also achieves this animation. Let's see some code, more code. Inside the recipe list item wrapper, you can see that it takes a child and the keep alive that we talked about, and the scroll direction is also passed down to it. We have inside the init state the animation controller and a scale animation. This scale animation is given a curve that is an interval. We will cover this shortly, but this is a form of staggered animations. We also define a perspective animation and alignment animation. And this is the multiplier that we saw earlier. This is the -1 and 1. This is where we use them inside the perspective animation and the alignment animation, which also take a tween to animate between a value and to animate between two values. Oh, I went 3 slides below and it was right here. Yeah. And this is how you define those animations and use them inside the animated builder. Let's see what Flutter staggered animations are. They are a form of overlapping animations. So sometimes you want to define two animations, hook them up to the same animation controller, but you don't want them to happen at the same time. This is where Flutter staggered animations come in. The interval allows you to give them a start and end value between 0 and 1. So if the duration of the animation controller is 1 second, and you give the interval of 0 to 0.5, you are animating only half a second. This can be very useful in this case. This is also a list view, and here we are applying this animation. The interval starts with a value that is the index divided by the item count, which achieves the animation of consecutively animating each list item, and they all end at the same time. Okay, that was only 2 points of the talk, but don't worry, the remaining is a little bit more fun, I hope. We covered scrolling animations, we covered the basics of animations. Now it's time to do the complex hero animation that we see here. So when I say hero, you can see the cheesecake image animating into view, like moving from the previous page to the next page. This is what we call hero animation. And this is done very easily with Flutter, just a hero widget. But we have to do some optimizations on it to make it smoother. And this is how it looks like on web. And what we have here is that aside from it being an hero animation, when you scroll down in the list, it will rotate with it. And we need to make sure that if you're scrolling down and then returning to the previous page, that you preserve this angle that the cheesecake is rotating in, so that it doesn't like snap back, because the hero animation by default takes the image but doesn't handle the rotation that it's happening in. So if you don't handle this case, it will be rotating in an angle, and then when you pop the page, it will snap back to its position and the animation won't be smooth. Let's see what this is in the code. I'm actually overriding the page transition, by the way, because if you remember, page transitions by default happen by the page sliding in, and I don't want that to happen with the hero animation, so I'm doing a fade transition. And by the way, you don't need to worry a lot about all the code. You can find it in the repository. I will share it at the end of the talk. So just ignore everything else that I'm pointing on. This is simply how a hero animation is achieved in Flutter. There are two requirements. You have to give it a tag, and this tag needs to be the same. So basically, there are two widgets, right? The one in the initial page and the one in the next page. So these both widgets are animating like they are the same, but in fact, they're not. But Flutter handles all that for us by having a tag that is the same in the previous and the next page. And also, the hero animation works best if it has the same child widget tree. So usually to make sure this happens, I usually do this as a single widget, and I use it in both pages. This ensures that I have the same tag and the same child widget tree. And if you remember that the hero animation is affected by the rotation, this is happening by using another way of listening to scrolling. We are including it in a custom scroll view. The custom scroll view takes a controller. So the scroll controller is hooked up with the listener, and the listener works similarly to the notification listener widget that we used before, but just in a different way. Both ways are okay, but you can choose whatever you want to use. And this is how we're listening to the scroll position so that the rotation happens while we're scrolling. It changes based on the position. You see here the rotation angle changes with a fraction of the position. If you make this number very big, it will rotate 1,000 times, and it will be very distracting. This angle is then passed to the transform rotate widget inside the hero to make it rotate. Okay, let's see a quick breakdown of the hero code. But before that, if you remember, in the web view, there was it was a horizontal view of the graphics on the left and the list on the right, but on mobile, it was vertical. This is achieved by creating a sidebar and a sliver up bar. And with an if statement, we can include either one of them. This screen size is something I created. It's an enum, and you can see it in the repo. Okay, so this is what makes or breaks the hero animation. We are making sure that in the recipe page, when we pop the navigator, we pass back the rotation angle, and inside the recipes list page, we use it to change the hero in the first page, and also to give the variable back into the next page. So this is a bit confusing. The main idea is to preserve this angle all the time, so that whenever I'm popping and returning, it's the same angle always, and nothing snaps and ruins the hero animation. Now, time for the gyroscope effect. I'm not sure if it's clear. Okay, you see the shadow of the pattern? It's moving according to the angle of the gyroscope, and it helps it gives it a 3D look, and we will see how we can implement that using a package. It's the Sensors Plus package. It also has like other events that you can listen to, like the accelerator of the device, and it works pretty well. It gives you a stream that listens to the X, Y, and Z axes of the rotation. Here we only care about the X and Y axes. So when the phone rotates around the X axis, I want to change the Y offset. And when it rotates around the Y axis, I want to change the X axis. So this is why they are reversed here. However, again, for performance optimization, I usually prefer to use a stream provider using Riverpod. You can choose whatever state management package you prefer. But this way, I can make sure that the stream is being listened to only once, regardless whether I use the gyroscope effect widget in multiple places. So this is how I can use it with a consumer from Riverpod. And this is basically the same way. Just using Ref Watch, we can listen to the gyroscope stream provider. Okay, let's see the build function of the gyroscope effect widget. I am basically here giving it two options. We can either give it a child builder, so that I can include whatever widget inside it, and the child builder provides me of the X and Y values. Or I can just provide it with a child, and this code will run. It will wrap it automatically with a tween animation builder again, and run the animation on it. By the way, the child builder has this type, and this is the offset that can be used in the child widget. This is how the constructors are differentiating between the child and child builder. So if I want to use the child builder, I can use the dot builder. This is the syntax similar to Flutter widgets, so it's familiar and causes the code to be more consistent. This is how we can use it with the child widget. It's just a gyroscope effect widget. You give it a child, and it will like move with it. So imagine whatever widget you have and you want to move it, you can use it like this, and it's very easy. Or you can also use the builder, which gives you the offset, and you can then provide the offset to the child widget. By the way, this offset multiplier here will cause I'm moving the pattern and I'm moving the shadow, but to give it more of a 3D look, I want to move the shadow further than the pattern. So I'm doing I'm multiplying it with a value so that the offset is different. And that's it for the gyroscope effect. However, we want to make it look good on web as well. So as an alternative, I'm using this method such that instead of your eye being the source of the movement, the mouse pointer is the source of the movement. Like the shadows are looking at the pointer and moving according to it. This is in fact created in a way very similar to the gyroscope effect. So if the code is not clear, you don't need to worry. It's like it has a regular constructor and a builder constructor. However, inside the build method, we have a mouse region widget, which is a widget provided by Flutter out of the box. And you can listen, like when the mouse enters this widget, you can, from the on enter, on hover, and on exit callbacks, you can get the offset value and listen to the mouse pointer location. And if you see here, there's an offset from mouse position method that I'm using, which under the hood uses the alignment from offset method, which figures out the alignment of the pointer based on where the pointer enters. Like if the pointer is in the top right quarter of the image, it will say alignment.top right and so on. And this alignment in Flutter has the following values by default. Like the top right has the top +1 and right is -1. So multiplying this with X and Y values from the X and Y values of the pointer will define in which direction the offset is going. This is a bit confusing, but you can get used to it once you see the mouse moving on top of the image. And this is the build child method that we see inside the mouse region effect widget. This is similar to the gyroscope effect, same way, either a child builder or a child. And that's it for the mouse region widget. However, if you notice, the mouse effect and the gyroscope effect were very similar, like very similar widgets. They can be used exactly the same way. So why not create a shared widget that you can use anywhere in your app, and you can be sure that this effect will happen as a gyroscope on your mobile or as a mouse region on web. So this is why I created the adaptive offset effect. The constructors are the same. However, the build method only decides based on the target platform if to show the mouse region effect widget or the gyroscope effect. And that's it for the whole animation. So as a conclusion, I want to just give you a couple of tips about animations in general. Remember that what you do in animations, once you go like one step further, you can achieve very great animations, and you can do that with attention to details, like what we did with the hero animation, making sure that it doesn't snap or ruin the animation. And you should always optimize for performance and responsiveness. And just to give you like a disclaimer, the animation that you saw is too much. Like I shared it on Twitter once, and designers were commenting that developers complain that designers create too many animations, but look at this. And I was receiving hate comments. I was actually trying to like showcase what Flutter can do all at once. In general, you shouldn't do a lot of distracting things, so you should optimize also for user experience. And that's it.